Welcome to EDU Aero classes. In this tutorial, we will discuss differentiability. Under differentiability, we will discuss the topic differentiability at a point and differentiability in a set. Firstly, we will see differentiability at a point. A function fx be a real valued function defined on the open interval ab. It is and let c belongs to ab. There is a real valued integer that belongs to open interval ab. Then a function fx is said to be differentiable or derivable at x is equal to c if and only if limit x tends to c of fx minus fc over x minus c exists finitely. Means if this limit exists, then a function is said to have derivable at x is equal to c. This limit, this limit is called the derivative or differential coefficient of the function fx at x is equal to c, and we denote it by f dash c or d of fc or d over gx of fx at x is equal to c. Limit x tends to c fx minus fc over x minus c exists finitely means that limit x tends to c positive, that is right hand limit of fx minus fc over x minus c should be equal to left hand limit, that is x tends to c negative fx minus f of c over x minus c. This right hand limit is called the right hand derivative and it is noted by r f dash c, and this is called the left hand limit. Uh, Left hand limit is called the L f dash c, that is left hand derivative of function at x is equal to c. Let us see through an example. In this example, it is given that we have to discuss the differentiability of a given function, that is x mod x at x is equal to 0. So here c is equal to 0 and fx is equal to x mod x. So fx is equal to x square when x is greater than 0, is greater than equal to 0, minus x square when x is less than 0. Okay, because x will be a mod of, if we clear this concept, because uh, mod of x will be positive if x is greater than 0, then it will be x. Mod of x will be negative if x is less than 0, that is it. Okay, and it will be negative. So by using this concept, we formulate our function, that is fx is equal to this. Now we will find our left hand derivative and right hand derivative. Now left hand derivative at x is equal to 0 is equal to limit x tends to 0 negative f of x minus f of 0 upon x minus 0 is equal to limit x tends to 0 negative minus x square minus 0 upon x minus 0. We take here function minus x square because here x is less than 0. So we take out this function. This come out to be limit x tends to 0 negative of minus x, which is equal to 0. Now we will find right hand limit at x is equal to 0. This will be limit x tends to 0 positive fx minus f of 0 over x minus 0 is equal to limit x tends to 0 positive Here we will take function x square because x is greater than 0 upon x minus 0 is equal to limit x tends to 0 positive of x is equal to 0. Here left hand derivative is equal to right hand derivative. So above function fx is differentiable at x is equal to 0. Hence this is our answer. Next we come to differentiability in a set. A function fx defined on a open interval AB is said to be differentiable in open interval AB if it is differentiable at each point of AB. That is, if AB is an interval, then at each point between A and B, it should be differentiable. So, the above function will be said to be differentiable in an open interval. A function fx defined on a closed interval AB is said to be differentiable if it is differentiable on open interval AB and if the x tends to A, it means right hand limit at A, it should satisfy right hand derivative at A and left hand derivative at B. Both should exist. Or in other words, we can say that left hand derivative at A and right hand derivative at A should exist and left hand derivative at B should also exist and it should also be differentiable on an open interval AB. So if a function satisfies all these three properties, then a function fx is said to be differentiable in a closed interval A.